So then we're going to start with the powers of 10. So scientific notation is just about the powers of 10. There for you. Okay, so when you have a decimal, right, the decimals are going to start here. This is what we learned earlier this week, that anything to the 0 power is 1. Okay, anything to the first power is itself. 10 squared means 10 times 10. 10 cubed means 10 times 10 times 10. And then when you get into the decimals, we're going to write the places. And some of you can probably help me with this. So when you have decimals, anything behind the decimal in this place, do you guys know what this is called? One decimal behind? What place is one decimal? Yep, the tenths. Great. Okay, so that's going to be one decimal place. What if it's 2? What's that called? Hundredths, yep. Okay, and then after the hundredths is the what? Yep, thousandths. And then if you have to go out to the next one, it's the 10,000ths, then the 100,000ths, then the millions, but we rarely go out that far. All right, so something else that we learned is whenever you have a negative exponent, to make it positive, you put the number under 1 and you raise it to the positive power. So 1 over 10 is 1 over 10 to the first. 1 over 100 is just 1 over 10 squared. And 10 to the negative third is 1 over 10 to the third. Okay, so that's what we practiced yesterday. Okay, so each time you're dividing by 10, the exponent is decreasing by 1, and the decimal moves one place to the left. So when you are dividing by 10, you have a negative exponent. So whenever there's a negative exponent, you are going to move the decimal to the left. So negative exponent means the decimal moves left. Okay, so what that is dividing by 10. You're moving one place to the left for every time you do that. Now, each time you multiply by 10, where are we going to move the decimal, you guys think? If it's increasing. Well, if it's negative, it's going to move to the left, so what's our other situation? So if it's not a negative exponent, what kind of exponent are we going to have? What's the other type of exponent? Positive, yeah? So if it's a positive exponent, that's when you're going to move to the right. Okay, so right now we're just going over the rules so that when we get to the problems, we'll be able to do those. Okay, and then we're also going to talk about a few tricks, and maybe you already know some of these things. Okay, so you might know some of these patterns already. So we're going to find the value of each power of 10. Okay, we're going to find the value of each power of 10. And here's a little trick for you. If you have a positive exponent, okay, that is going to be equal to the number of zeros. So if you have a positive exponent, that exponent is equal to the number of zeros. Okay, so Reagan, when we're looking at this, the 10 to the 4th, can you tell me which one is my exponent? Yeah, the 4. Okay, so if your exponent is 4, that means there's going to be 4 zeros, okay, after the 1. So this is going to be 1, and then 1, 2, 3, 4. Do you guys know where to put the comma in a number with those zeros? So normally we start from the back, and then we count how many? 3. 1, 2, 3. So this is going to be 10,000. Okay, and then we can check that. So if we do 10 to the 4th, okay, you should have 4 zeros here. Okay, I think this trick is faster than even just plugging it into your calculator. Okay, so Gabe, for B, how many zeros am I going to have? 9. Okay, so it's 9 zeros, okay, because it's a positive exponent. So the 9 zeros go after the 1. So I'm going to put a 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, comma, comma, comma. Do you guys know how to say this number? So this is the 100,000s, right? So this would be the millions. And so this is going to be 1. So this is the 100,000s, millions. This would be billion. And then trillions will come after the billion. Okay, now for these, there's 2 different ways that you can think of this, okay? So one way you can think of it is what we did yesterday. So if you have a negative exponent, okay, if the exponent is negative, there's 2 things you can do. One thing is you can put it over here and you can make it positive. This would be 1 over 10 to the 4th. Okay, and then what you could do from there is, if it's to the 4th, I know I'm going to have 4 zeros. And then what you could do is you could put that decimal in its place here. So if it's in the 10,000s place, okay, what you would do is you would count the places. So you have the tenths, the hundreds, the thousands, and then the 10,000s. So this would be the tenths, hundreds, thousands, 10,000s. Sorry, I know that's barely readable. Okay, so it's the same thing that we did above. So you have the tenths, the hundreds, the thousands, the 10,000s. Okay, and then if this is 10,000, you put a 1 here, and all of these are going to be zeros. Okay, so this is where it comes from. I'm going to teach you another shortcut, okay? So the shortcut is, if it's negative, you take that value, and how many zeros do you have in front of the 1? 3. So it's always going to be 1 less, okay? So if it's -4, there's going to be 3 zeros behind the decimal. Okay, and that comes from doing this, which this is likely what you guys did in science. Did you guys put a 1 and then move the decimal 4 places? Okay, so you did 1, 2, 3, 4, and then what has to go in each one of these spaces? A 0. So this is your final answer. So sometimes when the numbers get higher, it's harder to keep track of those spaces. Okay, so you can also just move 6 places left, but you have to start with the 1. Okay, so if you move 6 places left, how many zeros are you going to have? Yep. 1, 2, 3, 4, 5. Okay, so if you move 6 places left, there's going to be 5 zeros. So 1, 2, 3, 4, 5. Okay, so you are welcome to use this shortcut. I just want you to understand how this is relating to what we did before. Okay, but you can use that shortcut when you're doing your practice, okay? All right, the next thing we're going to do is the reverse of what we did here. So we're going to write each number as a power of 10. So just like we did before where we counted the zeros, let's count how many zeros we have here. Okay, so Keith, will you help me with A? How many zeros does that have? For part A, how many zeros do you have there? For part A.
Part A?
Mm-hmm. So how many zeros are behind the 1?
6.
Okay, so if there are 6 zeros, we're gonna do this in reverse, right? Okay, so if there were 9 zeros, we had 10 to the 9th. So if there's 6 zeros, it's gonna be 10 to what power? Yeah? Okay, now B has a decimal in it. So if there's a decimal, that means that it's going to be what type of exponent? Yep, it's going to be negative. Okay, so one way that you can do that is you can just count 1, 2, 3, 4. Okay, so if you move 4 places to get to 1, okay, it'll be 10 to the negative 4. Okay, it's also 3 zeros in front of the 1. So if it's 3 zeros in front of the 1, okay, it's 1 more. Okay, so let's do C. So is that going to be a positive or a negative? Positive. Okay, so for that one, 3, what would you get for C? Great, 10 to the 3rd. Oh, good, your voice is back. Okay. Okay, so 10 to the 3rd. All right, nice work. All right, so the next thing we're going to do is we're going to find the value of each expression. Okay, so what we're going to do is we're going to move that decimal to the right. Okay, so if you have 10 to the 8th power, okay, you're going to move the decimal right 8 places. How many of you think you can do that without me? Just move the decimal from where it is, 8 places, and put the zeros in. So you have 23.89. All right, go ahead and move it 8 places. Okay, so when you're moving the decimal, Gabe up here. Okay, when you're moving your decimal, 1, 2, and then 3, 4, 5, 6, 7, 8. All of these have to be filled in with what? Zeros. Okay, so how many zeros do we have? 6. So we move the first 2 behind the numbers, and then we have 1, 2, 3, 4, 5, 6. Okay, so some of you were doing like the 10 to the 8th there. And if you did multiply those together, you would get the same thing. Is that usually what you do in science? You write it and then you multiply? Or no? In science, do you usually write this out, or do you put that in your calculator? That part? All right, so this number here, again, you have the 100,000, you have the millions, so this would be 2,389,000. All right, now this one had the decimal in it. This one, you can't see a decimal. Do you guys know where the decimal goes if you don't see it on the number? Yep, in the back of it. So if it's 467, the decimal goes right here. And the -3 means you're going to go to the left. Okay, 3 places. Okay, so then if you move it 3 places to the left, 1, 2, 3, okay, your final answer is 0.467. Okay, so anytime you have a whole number, okay, so whole numbers are numbers without decimals. So for whole numbers, the decimal goes at the end. Okay, so it goes after that number. Okay, and then if they give you a decimal, if the decimal is already in there, that's great, because then you're just going to move it from that place. So you have 0.163. Okay, so Avery, what does this -2 mean? What am I going to do with that decimal? Yep. So move 2 places left from where your decimal is. So I'm going to go 1, 2. Anytime you have an empty space, you're going to fill it with a 0. Okay, is a lot of that review for you from other classes? Okay. All right, so I was hoping that most of that would be review. And then what we're going to do is we're going to apply this to some story problems here. Okay, and then this is scientific notation that we're going to talk about. So again, some of this might be familiar to you. So the scientific notation, the reason why we use that is because there are numbers that are very, very large or very, very small. Okay, and it helps save us time by rewriting them. And honestly, sometimes the numbers are so big, your calculator can't compute them all. And so that you'll see actually a letter on your calculator. Have you guys seen that letter before? Is there a letter on your calculator that you've talked about in other classes? Okay, we'll talk about it today then. All right, so the first part of a number, this is important. When you're writing it in scientific notation, okay, the first part of a number has to be greater than or equal to 1, but also less than 10. Okay, so all this means is it's a number between 1 and 10. Okay, so this part is important. Some of the ones we had on the front were not in scientific notation because the number was not between 1 and 10. Okay, now the second part is a power of 10. Okay, which we did see on the front. So 10 to the -2 or 10 to the 11. Okay, so for example 4, Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Okay, first, do we know what the diameter is? Maybe we should draw Saturn. You guys want to draw Saturn today? A little replica? Were any of you into space as a kid?
I was more of a dinosaur child.
Oh, dinosaurs. My nephew has like this carpet. It has all the planets on it. I was trying to quiz him this weekend. Just like, which one is the planet with the rings on it? Yeah. Okay. And on the carpet, there was only one of them with it. Okay. So diameter is a term that's used with a circle. So the diameter would mean you go through the center of Saturn and you go all the way from one side of the planet to the other. So that would be without the rings because those are outside of the circle. Okay, so when you guys talked about circles, did you talk about the radius and the diameter? So the diameter goes all the way across, okay, and the radius is half of the diameter, so that's your R. Okay, so that's just some terminology so we understand what's going on here. Okay, so Saturn has a diameter of about 1.2 times 10 to the 5th kilometers. Okay, its distance from the sun is about, and then we have this large number, okay, so we have the hundred thousands, the millions, billions. So 1,427,000,000 kilometers. Alright, so this here is given to you in standard form, or sorry, this one's in standard form, this is in scientific notation. So we're just going to label that. Okay, so this is write Saturn's diameter in standard form. That's because it's given in scientific notation. We want to write it in standard form, which looks like this. Okay, so it's important that we do those labels because the question is going to ask you for a certain form. If we don't understand what that means, it's going to be really hard for us to answer the question. Okay, so if we're going to write this in standard form, we're going to take the 1.2 times 10 to the 5th. And how many of you think that you could just do that without me in standard form? Because it is what we did on the front side. Okay, so go ahead, give it a try. Okay, now if you did that without me, then hopefully what you did is you moved the decimal 5 places to the right. Okay, so you're going to go 1, 2, 3, 4, 5. Okay, for every one of these, you have to put in a 0. Now when you write your final answer, we're going to write the number and then start from the back. And then we're also going to include the units. Okay, so if it's given to you in km, do you guys remember what km means? Yep, kilometers. Great. Okay, so it's 120,000 kilometers. Okay, and then we're going to have to do the reverse. So this is write Saturn's distance from the sun in scientific notation. Okay, so they actually already give you the value. You just have to write it in scientific notation, but you have to know the definition in order to do that. So let's write this in standard form. Okay, so I'm going to write 1,427,000,000,000. Okay, and I'm not going to put my commas in because I'm going to put in a decimal. Now, the decimal has to be between 1 and 10. So when you're thinking about where your decimal goes, okay, understand you have different options, right? So with your decimal, where would I put it so that my number would be between 1 and 10? Do we know what two numbers it would go between? Yeah, between the what? Yeah, the 1 and the 4. So if it was 1 point, and then we'd have to put the 427. See how this number's between 1 and 10? But if I put it here, would this be between 1 and 10? No. Okay, so that's greater than 10. So we wouldn't be able to do that. Okay, it has to go there. So when you do that, if it's not a 0, you have to include it. So when you're doing the scientific notation, we're going to start with 1.427. It's going to have to be times 10 to a power. Okay, so to figure out the power, we just have to count how many spaces it would take to get to the end. Okay, so let's check. 1, 2, 3, 4, 5, 6. How many more spaces do I need? 7, 8, 9. So this would be 9 places, okay, to the right. Okay, so yeah, there were 6 zeros, so we have to add that on to this 1, 2, 3. Okay, so if you want to count the zeros, then you could add that on there. Okay, and again, we need to put the decimal there so that this number is not bigger than 10. Okay? Okay, so for the last one, we just have to order the list of numbers from least to greatest. Okay? So for me, like, this is hard to look at. That looks like a lot of numbers close together. I don't like that. Okay, so what I do is I like to separate them, okay, like this, so I can see each number. But I'm a very visual person, so for some of you that might not bother you, that's fine. Okay? So I have 1, 2, 3, 4, 5, 6, 7 that I have to order. So in order to do this, what you do is you order by powers of 10. From least to greatest. Now this task isn't difficult, it's just kind of tedious because you're organizing them in a list. But we know that we have 7, so why don't we make a list of 7 here? And then what we're going to do is we're going to find the least one, okay? So if you're ordering from least to greatest, I'm looking for the highest negative. Okay, which one of those has the highest negative number as the exponent? Yep, the last one has 10 to the negative 3. Is there anyone that's less than -3 or the same? Yep. Okay, so this is what we have to do when we're organizing those two. Okay, we have to put the smaller number first. So if those are the same, these are going to be the least. So let's look at the numbers. We have 5.4 and 467. Okay, which number is smaller? 5.4. So the first thing we're going to write is 5.4 times 10 to the -3rd. And then the next one is 467 times 10 to the -3rd. Okay, nice work with that one. All right, so now I'm looking for an exponent that's higher than -3. So what would that one be? Yep, I have a -2 here. This is 3, 6, 6, and then I have another -2. Okay, so do you guys think that you could order that one? Which number is lower? 1 or 1.3? 1 is lower. Yep, so that's going to go first on our list. Okay, so if the powers are the same, you're going to pick the lower number. Okay, so this would be 1.3 times 10 to the -2. Okay, great. What's the next highest exponent? Yeah, you have the 3 there. And then are there any other ones with 3? Nope. So 6.3 times 10 to the 3rd. And then the last two have the 6, right? So if they're the same, okay, if the powers are the same, you just list the lowest number first. Okay, so that's why you can see I'm underlining this. So it's 4.1 and 2.1. So which one's going to go first? Yep, so this is the smallest, this one is the largest. Okay, so this one is the least, this one is the greatest. Okay.